Today we are talking about inductive reasoning. So this chapter is about reasoning. It's on page 54. It's not really a geometry chapter. It's more about logic. But logic is useful for doing geometry things like proofs. So this is kind of warming us up for geometry stuff. I thought, well, maybe we can skip this chapter, but then I thought, well, some people aren't really great with logic, so maybe we should practice some girls. Anyway, so I thought this would be maybe some good practice for our brains to get used to. Okay, inductive reasoning is something you use every day without realizing it, without giving it a title or anything. It's just kind of something people do. Okay, if I was sitting in the computer lab, well, somewhere inside, and people started walking in and they were all wet, what might I assume?
It was raining.
It's raining outside. Okay, that's inductive reasoning. You've had experience in the past with when it rains outside, people get wet and they come in. Anyway, that's inductive reasoning. So inductive reasoning is using past experiences to predict the future, basically. Inductive reasoning is using past experiences to predict what's going to happen in the future. Now, is it possible that my assumption was wrong?
Yeah.
Because what else could happen?
They could get water. They could get pranks.
Okay, they could have been in a water balloon fight, or
They could get pranks from the water being on like the door and then walk in and they open the door and the water.
okay, some
Who
kind
said
of.
it was water?
Anyway, so inductive reasoning is not 100. Inductive reasoning is not 100% proof. It's just likely to be true, but we don't know for sure. But based on past experiences, this is what we think is going to happen, or what is happening. So, if I said all mammals, no, sorry, let me say that a different way. If it has hair, it's got to be a mammal. Because my experience, everything that has hair is a mammal. Is that a true statement?
No. What is the
Okay, it's not a true statement. Why is that not a true statement?
They are very bizarre animals.
Because we have very.
We're mammals too.
Well, I guess.
They are very bizarre animals.
Okay, Will, like what?
I can't remember it exactly, but I do.
The furry whale. The whale's called.
Okay, whales are mammals.
That's what I said.
I'm pretty sure there's some like in
Sharks are not mammals, but they don't have hair.
Don't they give birth?
Huh?
Is it seals?
Seals
Seals
are mammals.
Don't sharks
I'm
give
pretty
birth?
sure there's a bizarre amphibian or
Okay.
They don't lay
Penguins?
Penguins, that's feathers.
Fish.
Okay, you guys can't think of an example?
Sharks don't
Yeah.
lay eggs.
Okay, here's what I said. If it's got hair, it's got to be a mammal. Is that a true statement?
My man.
Yes.
For now it is.
Okay,
I am.
you guys can't think of anything else that has hair. We're mammals.
insects.
I just said that. They don't have hair.
Insects.
Okay, kiwi has something like hair. Spiders and insects also have hair, right? So what that is, the spider example, that's called a counter example. So how many counter examples do you need to disprove a statement? One. So if you can give a counter example, that's like saying, no, that's not true because this. So inductive reasoning helps us figure out things that are probably true based on the evidence. Now, in a court of law, if somebody gets shot and they can tell like the bullets from your gun, they're probably going to assume you're guilty, right? That's a kind of inductive reasoning. Usually the people who get shot with your, if somebody gets shot with your gun, it's probably you that did it, right? Is that 100% true? No, but it's likely. What's in the court of law? What do we use as our measuring line for if you're guilty or not?
Reasonable doubt.
Reasonable doubt. So it's kind of a vague statement, but is it beyond reasonable doubt? So sometimes yes, sometimes no, but it's hard to know things 100% sure sometimes, but all right. You guys know what a truism is?
It is true.
Huh?
An absolute truth.
No, it is not an absolute truth. If it was absolute truth, we would call it truth, or just true. A truism is something that is generally true. Okay? So it's kind of related to this. Now, we're trying to figure out the truth using inductive reasoning. We don't know for sure it's the truth, but it definitely is or isn't the truth. Truisms are things that are usually true. Like, some people say like the book of Proverbs is truisms. Like, it's usually a good idea to, like something it says in Proverbs is the person who borrows is slave to the lender. So they're basically saying it's not a good idea to get in debt. Okay? So that's a truism if you can avoid it. But almost every American is in debt because of, you guys know why?
Because they want something.
Okay, student debt.
Yeah.
That'll be you guys in a few years. If you can avoid it as much as possible,
I'm not gonna be.
you're not going to go to college.
Yeah, probably.
Or,
I'm gonna be sick.
well, one option is you could like work and take classes part-time or something if you had to. Anyway, or when people buy their houses, almost everybody buys it with debt. But anyway, it's a truism that you want to avoid that if you can. Now, I went ahead and got a house and got in debt because I was paying rent, and wasn't buying me anything, so I went ahead and bought a house anyway, even though I couldn't pay it all off. Yeah.
How much is the average house cost up front?
I have no idea.
No,
So
yeah.
probably the cheapest you get at a house is probably $20,000, like, and that would be a fixer-upper, let's call it that. And the most expensive is in the millions. But I would guess maybe an average Bartlesville house is 100,000.
100,000, that's upfront.
Or you
On a
could
down
just-
payment, just upfront.
Well, down payment is just depends.
Yeah.
Or you could just rent in that
What you
like
bought?
your house,
Do
and
it.
your landlord has to pay for it.
Yeah, we have to actually make the landlords who will fix it,
Yeah.
because some don't.
Or at least they should.
Anyway, landlords don't have houses, they have apartments.
Landlords are in the car.
No.
No, my opinion-
Landlords own property that you rent. Anyways. Well, sometimes they rent houses, I guess. I'm getting off topic here. So, turn in your books to page 56. We need to chat about that.
Where did I put my book at?
There's 5 circles under the circle. 3 squares in the front.
Thank you for your hair. Lower. There.
Emily, there's something in your hair.
Okay, so what you need to do on 1 through 9 is find the pattern, fill in the missing blanks using the pattern. And some of those are kind of tricky. If you need help, you can ask. Do you guys know what, like on 4 and 5, they have some diagonals. Do you guys know what diagonals are? We kind of talked about this once.
No.
Diagonals are lines that connect the corners. Like that. Goes from one vertex to a non-adjacent vertex. So it just connects the, So in checkers you move diagonally, right? But in geometry a diagonal is a line that connects a vertex with another vertex. Another thing you need for today's lesson is to remember what a prime number is. Do you guys remember what a prime number is?
It can't be something.
A number that's only divisible by itself in 1.
Exactly. A prime number has exactly 2 factors, the number 1 and itself. 1 is not a prime because it only has one factor. So what's the smallest prime?
2, 1.
2. I just said 1 is not a prime like 3 seconds ago. Okay, anyways, 2 is the smallest prime because the only thing that goes into 2, 2 times 1. Is 3 a prime?
2, 3, 5.
Is 4 a prime?
No.
No. Is 9 a prime?
No.
No, because 3 times 3. No, that's out.
Wait, you can't do. Wait, say that again.
7?
Wait,
Is
what's-
9 a prime number? Only has 2 factors: the number 1 and itself.
So you can't do like 10 wouldn't be one.
10 is not a prime. If it's not a prime, it's called a composite.
13?
13 is prime.
11?
11 is prime. Yeah, lots of odds are primes. 9 is not a prime
17.
because 3 times 3.
Wait, so like any of those numbers up there, like
17.
I can't do 5 times 5 to get 25, and 25 is a composite or whatever you said.
Yeah,
So 7 times 7, that's 42, right?
49.
49,
That
sorry.
would be a composite.
That would be a composite.
23?
43 is prime. There's composite means it's not prime.
I don't think there's paper in here.
No, there's highlights.
Just leave it.
I can't even reach it.
Okay, also on number 17 on page 57. So it says verify Goldbox conjecture. So a conjecture is just like an idea using inductive reasoning. You're saying this, I think this is true because it seems like it's true every time. So his conjecture was that you can use 2 prime numbers to add up to any even. So any even number greater than 2 can be added up to using 2 prime numbers. So on 7, what 2 prime numbers could add up to 4?
2.
2 and 2, right?
Yeah.
So on 17, you can just put 2 plus 2 equals 4. That's what they're looking for. Just use 2 primes to add up to that even number. What's another tricky one? Okay. Do you guys remember what the angles of a triangle always add up to? I don't think I mentioned it yet this year. 180.
Oh shoot,
180.
no, I'm thinking.
Hey, if I have a rectangle, what are the angles of a rectangle? What angle is that?
90.
That's
90.
90.
So, what would the angles of a rectangle add up to? 90 times 4 is 360.
That was what I was.
So if you saw another picture and it was like 60, 60,
90. 80.
let's say 120, 120, and you add those up and you get 360, what might you assume is true? If these add up to 360, these add up to 360, maybe a couple more examples.
Everything adds up to 360 when it's full squares.
Right. Quadrilateral angles add up to 360.
Yeah.
Okay, that's inductive reasoning. So, yeah, that is true. And it is a true statement. But you can't like look at every quadrilateral that could ever exist. You just kind of assume if everything we've ever looked at is 360, that's the case. All right. There are some tricky ones, but if you have questions you can ask. Good luck.